This lesson deals with supplemental problem 8.16. You can find this problem in the ECE202 ebook in the Chapter 8 Supplemental Problems starting on page 27. Given this triangle wave here, can you find the RMS value of it? To do that, we need to find an expression for the waveform over a period. So here I've got one straight line segment, here I've got a second, now it repeats itself. So let's take our period from minus t over 4 to 3/4 t. So in this interval here, I've got a straight line passing through the origin. We can just figure out what the slope is. So the rise is I sub a, and the run here is t over 4. So we take the rise over the run, we get 4 I sub a over t, where t is the period, times small t, which is t in seconds. Our second line segment is over here, and again, it's the equation of a straight line. It's going to start at t over 4, and it's going to end at 3/4 t. And the slope here, again, is rise over run. So I have a rise of I sub a, and I have a run of t over 4 minus t over 2, and that's equal to a minus t over 4. So the rise over the run gives me minus 4 I sub a over t times t. And then we also have the intercept of the equation of the straight line, and this is going to be where it crosses the y-axis when t is equal to 0. So in a quarter of a cycle, we change by a value of I sub a. So if I go another quarter back, this is going to run into the y-axis at 2 I sub a. So now I have my equation for my triangle wave, and I can apply my definition of RMS, which is going to be the root of the mean of the function squared. So let's square this and then put all that together. Squaring this, I get 4 squared, which is 16, and I sub a squared divided by the period t squared, and then times our time in seconds squared. This term over here, I'll have the first term squared, so I'll get the plus 16 I sub a squared over capital T squared times t squared. I'll also have this term squared, that's over here, 4 I sub a squared, and I've got the inner product times 2. So I'll get a minus 8 times 2, or minus 16, and then I'll have I sub a squared divided by t, and then times little t. So now we're going to take the integral over where this equation is true, and then where this equation is true. We're going to add those together. Okay, so the integral from minus t over 4 to 3/4 t, or a function squared, is this term right over here. Okay, and then our second term right over here would be going from t over 4 to 3/4 t, and has this expression right over here. All right, so we bring out this scalar in front, and then we're going to have the integral of t squared, which is 1/3 t cubed, upper limit minus the lower limit. For this term, same thing, I'll pull out the scalar in front, and I'm left with t squared, which is going to have 1/3 t cubed for its integral, evaluated from the upper limit minus the lower limit. And we'll take the integral of the next term, which has got this scalar, minus 16 I sub a squared over t. And then I've got the integral of just t, that's going to be 1/2 t squared, upper limit minus the lower limit. And lastly, I have the integral of just a constant, which is just going to be that scalar out in front, and the integral of 1 dt is just t, and again we're going to take the upper limit minus the lower limit. Let's evaluate this integral. So our first term here, we've got 16 I sub a squared over t squared. I'm going to pull out the 1/3, and then I've got t cubed, upper limit minus the lower limit. So then I've got the capital T cubed, and then I've got 4 cubed, which would be 4 times 4, which is 16 times 4 is 64. And I've got minus this term, but I'm going to multiply it 3 times. I'll get a plus sign from all that. Again, I'll have my 4 cubed, which is 64. Same thing over here now. I'll pull out that 1/3, and I've got the 3/4 now cubed. So I've got my capital T cubed, and then I've got 3 cubed, which is 27, and 4 cubed is 64. And then minus the lower limit, which is going to have t cubed, and then 4 cubed, which you found to be 64. This term, we've got the scalar out in front. I'm going to pull out the half with it, and then put the 3/4 in here for t squared. I'll get 9 over 16 t squared, and then minus quantity squared, which is going to be capital T squared divided by 4 squared, or 16. And lastly, this term here, I got 4 I sub a squared, and then 3/4 t minus 1/4 t. Now we can combine our terms here. So I've got 16 over 3. I've got a t cubed and a t cubed and a t squared, so it's left with a t. I have an I sub a squared. I have this twice. Okay. Term I've got, again, 16, and I've got I sub a squared. I've got the 3 from here. And then I've got this term here, which is the difference of these two, which would give me 26 over 64t. And then likewise for this term here, I'll have a t squared and a t, so I'll just have a t left over. The difference of these two would be 8, divided by 2 would be 4, and then I've got a 16 and a 16 canceling. So I just have 4 I sub a squared times t. Then this is equal to just a half of t, and then I've got 4 here, so I just have a 2, and then I sub a squared and t. And finding the decimal equivalent of these, first term is 0.1666, 2.166, minus 4, and plus 2. Adding all together, I get 0.333, which is basically a third. So the RMS value of this triangle wave is the root of the mean of the function squared. We found that this was equal to I sub a squared over 3 times t. Here the t's cancel. And I'm left with I sub a squared square root, and then I've got the square root of 3. So the RMS value of a triangle wave with a peak value of I sub a is the peak divided by the square root of 3. I'll contrast this to a sine wave, which has a similar formula, but it's the peak divided by the square root of 2. And this is supplemental problem 216.